Hi, I'm Bob McLean. Thanks for checking out my cybersecurity channel. In this segment, I want to talk about DNS, the domain name system, and its role in a ransomware attack. As you may imagine, I have some suggestions for configurations in your DNS setup so that your network does not help the ransomware attacker. And I'll get into how that happens. For the non-technical, DNS, the domain name system, is a global, internet-wide, network-wide technology that resolves human-readable domain names to IP addresses. There are servers, there are structured queries, and particular types of queries I'm not going to get into, but the whole DNS system of planet Earth and the internet works to resolve every domain name to an IP address. And somewhere, and for DNS to return a result to a workstation that asked for an address associated with a domain name, a record has to exist somewhere on the internet, and that domain is registered somewhere on the internet. So we have the basics. DNS is the lookup system. Now, how does that work in a ransomware attack? I've repeated and emphasized that a ransomware attack starts when a threat actor exploits a vulnerability on one machine and establishes that foothold privileged account. From there, the attacker spreads laterally, downloads additional malware, and eventually downloads the keys that are used to encrypt your entire environment. So when that foothold account is established, the attacker is using a workstation in your environment. That workstation has a DNS configuration. It has name servers configured in it that point to a local server. That may be within your network. It may be your ISP, depending on the size of company and number of workers. Sometimes everyone just points out to the ISP DNS server as its name server, or as their name server, or to a local machine that is acting as the DNS server. And then that local DNS server, when asked to resolve a domain that does not reside within its realm, will go, let's call it upstream, to another name server and ask for resolution. And I'm generalizing and skipping over a lot of technical detail here for the point of, just to maintain a focus. So when a local DNS server goes to its upstream neighbor, the entire infrastructure will work to resolve any request, whether it's google.com or ransomware.com or Joe's malware command and control server.com, whatever. So when that workstation in your environment makes that request, your entire infrastructure is working to provide the IP address to the command and control server. The command and control servers move around. They're not very static because they are, in fact, residing in another web server that's been hacked. There's no internet service provider, infrastructure, or hosting provider that's going to hang out a shingle and say, ransomware, guys, register here, I'll advertise, I'll host your ransomware code right here. They don't do that. They hack into a WordPress blog about cooking, for example, and stick a folder in there and with the files, and they have access to a web server that from which they can draw files. And they move. Once an address gets a reputation as being one that distributes malware, it's going to get blacklisted through the threat intelligence infrastructure. So how does this work for us? Well, let's look at the attack, right? So the ransomware operator tries to get to malware.com and makes a DNS call. If in fact you subscribed to a filtered DNS service, a DNS service or a service that provides DNS functions that are coupled with threat intelligence, and they're out there. If you subscribe to one of those, when your local server is unable to resolve that request, it's going to go up to its upstream, we'll call it its upstream neighbor, and we'll configure the filtered DNS server addresses as the upstream DNS servers. That looks up the destination address and compares it to its threat database and finds that it indeed has a reputation for distributing malware or is a known bad address, and does not return the IP address to the attacking workstation trying to complete the attack in your environment. So that stops the attack. However, we know that ransomware operators are crafty. They, after all, broke into your machine and are trying to navigate around your network with it. So it's not going to take them long, probably, if in fact they can detect, they can get to other areas like, or other domains like google.com, and they can't get to their own malware.com. They might put two and two together and come up with the fact that they're being analyzed. So they can change the configuration of the workstation that they're using, and they can configure that the name servers are global wide open name servers available from internet service providers. That's possible. So what we can do in response to that is configure edge security devices like firewalls and router access lists to nail down DNS traffic that's leaving your environment to only be allowed to the filtered DNS service. So if a rogue workstation or a compromised workstation tries to get out to a different DNS server, it's going to get blocked. This is pretty effective. It's kind of a blunt stick, but it is effective. It will prevent that attack. Now, the DNS, hopefully at this point, between getting or after getting a potential alert from the filtered DNS service that somebody's trying to go to a malware-laden or malware-ridden site, and then an alert, a syslog message being escalated from your firewall indicating that a rule that is preventing DNS traffic except to the filtered services, a rule that is protecting you, is being violated by someone. Hopefully your teams can respond, identify the workstation that's been compromised, and remediate it. So the ransomware attacker may or may not be able to circumvent and go direct IP. Hopefully the speed bumps we've put in the way have blocked the attacker long enough such that your security teams can detect a machine is compromised and take appropriate action. It's not necessarily the most elegant. It does not go back and clean the offending machine. This is blocking through other means, but it's a layer of difficulty that can be added to your environment to stop most or several ransomware attacks in progress. If they can't get to the command and control servers, they can't finish the attack. So why does one click on one machine lead to total ownage? It doesn't have to. I hope you found this interesting. Please let me know. And I'd appreciate a thumbs up, a comment, a discussion. Till the next time, take care.